Question 5. Figure 5 represents two glass flasks, P and Q connected via tap. Flask Q volume is that. It's filled with ammonia NH3 at 102 kilopascals and 200 Kelvin. Tap is closed and vacuum flask P. Gas constant R is that. Calculate the mass of ammonia in flask Q. So we're going to use the ideal gas equation, PV equals nRT, and we want the mass. So how do we get the mass? Well, before we get the mass, we need the moles. So N, number of moles, is equal to PV divided by RT, which is equal to pressure in pascals. So 102 kilopascals, 102,000 pascals, times by volume. Now volume is in centimeters cubed. We need to divide it by a million. So we need to times by 1 times by 10 to the power minus 6 to convert it into our correct units. So 1.00 times by 10 to the power 3 times by 10 to the power minus 6 divided by R, which is 8.31, times by temperature, which is 300 Kelvin. It's already in its correct unit, Kelvin. So we get the number of moles, 102,000 times by 1.00 times by 10 to the power 3 times by 10 to the power minus 6 divided by 8.31 times by 300. And I get 0.0409, and it keeps going on. So we know moles is mass over mR. So moles is mass over mR. Mass is going to be the moles times by the mR of ammonia. What's the mR of ammonia? Ammonia is NH3. Does it tell us in the question? Yeah, it does, NH3. So if you didn't know, which you should, but if you didn't, it's given in the question. So nitrogen 14 plus 3, so 17. So my answer times by 17, that'll give me 0.696 grams, and that is the mass of ammonia in flask Q to the appropriate number of significant figures. 5.2. When the tap is opened, ammonia passes into flask P. The temperature decreases by 5 degrees Celsius. The final pressure in both flasks is that. Calculate the volume of flask P. If you look back at the diagram, we know flask Q volume is 1.00 times by 10 to the power 3. What we're trying to find is the volume of flask P, this one. So we can do what we can find is a total volume using the information given, subtract it from the volume of flask Q, that will give us the volume of flask P. Okay, so the volume, well, we know PV equals nRT, ideal gas equation, volume V is equal to nRT divided by P. V is equal to number of moles of ammonia number of moles of ammonia times by 8.31, which you found out the number of moles of ammonia through 5.1, times by the temperature in Kelvin divided by pressure, which is 75,000 in pascals. the total pressure. To find the temperature, well, we know the original temperature is 300 Kelvin. 300 Kelvin. How do we convert from degrees to Kelvin? Well, we add 273. So to get from Kelvin to degrees, we need to minus 273. 300 minus 273 give me 27 degrees Celsius. And we know that the temperature decreases by 5 degrees Celsius, so 27 minus 5, which can be 22 degrees Celsius. And now we can convert it back to Kelvin, so add 273. 22 plus 273, 295. Substitute that in here. So 0.0409 times by 8.31. That should be a clearer point. Dot times by 295 over 75,000. Now I get 1.34 times by 10 to the power minus 3. Now what is this value? This value is a total volume. And we know that the volume in the question, volume of flask Q, is this. We know the total volume, so what we can do is we can do the total volume minus flask Q, and we can get flask P. So total volume 1.34 times by 10 to the power minus 3 minus 1.00 times by 10 to the power 3. So my answer minus 1.00 times by 10 to the power 3. Let me just put it in again. 1.34 times, put it in brackets actually, 10 to the power minus 3 minus 1.0 times by 10 to the power 3. I get minus what I misread is the idea that what I just worked out now is a volume in meters cubed, because I used all the correct units: Kelvin, moles, temperatures in Kelvin, pressures in Pascal. So that will give me the volume in meters cubed. This volume, however, is in centimeters cubed. So what we need to do to convert it from centimeters cubed to meters cubed is we need to times by 10 to the power minus 6. So this becomes 10 to the power minus 3. Then once we do that subtraction, and then times by 1 times by 10 to the power 6 to convert it into centimeters cubed, which will give me, that'll go and we'll get 10 squared, so that'll give me 342 centimeters cubed. And that is the end of question 5.